Hi guys, today I want to take a look at a new feature that's in preview on Azure Data Explorer. And this is very similar to what we looked at last week when we built an HDAP using Azure Cosmos DB with Azure Synapse using Azure Synapse Link. And with that solution, basically what we did is we have a Cosmos DB that is able to feed data into Azure Synapse. And then you can use Azure Synapse as an analytics processor, and you can use Cosmos DB as a transactional processor, and the two together create a very seamless experience where you can have both analytics and transactional data sitting side by side without having to do a lot of crazy kind of integration work using something like ETL. Well, with this solution, it's very similar to that workload, but this one, instead of putting data into Azure Synapse, it's going to put the data into Azure Data Explorer. And we'll unpack what Azure Data Explorer really is whenever we go through the demo, but that's where we're aiming at today. So the demo really just builds on what we talked about last week. So everything that's kind of upstream of Cosmos DB, I'm not going to rehash. Instead, I'm going to link a video in the video description below that you can use to show how to get from IoT devices into Cosmos DB. And once you're in Cosmos DB, there's really not much you have to do other than wire up Azure Data Explorer to receive the data from Cosmos DB. So let's review that flow, and then we'll go into the Azure portal and build this out and just show you kind of what that looks like. So this is the flow that we built last time we looked at this, but instead of having Azure Data Explorer, we had Azure Synapse. Today we're going to be looking at Azure Data Explorer. So to review what this is doing, it's pretty straightforward. We have devices that are creating data, which is events and telemetry. So my devices are basically just sending a bunch of telemetry data up into IoT Hub. Now IoT Hub wants to relay that somewhere. Now currently there is a native integration between IoT Hub and Cosmos DB that kind of skips these two steps right here. As of right now, that it's a preview feature that doesn't seem to work real well in my experience, so I'm not going to be using it. I am still going to use the more traditional pattern, which is using a messaging platform with integration, but this pattern will also be around probably after that integration becomes more natively available between IoT Hub and Cosmos DB, because there might be some things that you might want to do here that you wouldn't otherwise be able to do if you're just going straight from IoT Hub into Cosmos. But this pattern right here with a messaging platform and an integration platform give you a lot of variability in what you can use. So the IoT Hub can relay a message to a messaging platform on Azure, which could be something like Service Bus, an Event Hub, or an Event Grid. And depending on what your needs are, depends on which one of those you will choose. I went with an Event Grid, which works just fine. Now, from the Event Grid, you can then wire up something to receive the message from the messaging platform. That's integrationware. Now, the integration is basically taking the message and putting it into some kind of data store. And there's any number of options on Azure for that. You could use something like function apps, you could use stream analytics, you could use logic apps, or some other solution. But those are the three main ones. I went with a function app for mine because a function app is pretty straightforward. I wrote some Node.js code that basically took the message and put it into Cosmos DB without doing any kind of enrichment or analysis on it. So it was pretty lightweight in terms of the integration that it was doing. And once it's in Cosmos DB, it's in my transactional store, which is fine. We're doing just some standard queries against that data. So if I was going to build an API, I'd probably want to use the Cosmos DB store for that. But if I want to do some analysis on that, I want to put that data into an analytics store, which we looked at last time was Azure Synapse, which is an analytics solution on Azure, which integrates a lot of different features and functions. Now, that integration works great if you want to do some of that data warehousing type analysis. But if you wanted to do something that was more time series oriented, which you can do that at Synapse, but you wanted a more specific solution, Azure Data Explorer is a great option for that. It's not exactly an analytics database like Azure Synapse is, but it's not a transactional database either. It's mostly aimed at doing real-time data analytics or near real-time data analytics. So it allows you to ingest data from a lot of different sources like event hubs, and in this case, Cosmos DB, and store that data and then use a custom query language that's called Custo to analyze that data. And so that's what we're going to look at today. So this would be good for things like time series data or any kind of data that you want kind of real-time analytics on, that you want to feed into something that's not a transactional store, but something that's optimized for that kind of workload. In this case, Data Explorer is the choice on Azure. So I'm here in the Azure portal, and I already have my instance of Cosmos DB created. I created an Azure Data Explorer cluster already too. That can take a few minutes, but I'm just going to walk you through that process. There's a couple things you need to turn on when you create one of these if you want to do this ingestion. So if you just go to create this, you can type in Data Explorer here, or you can type it up here in the search, whatever it might be. Just find the link to create a new instance of this. So I'm going to go to Azure Data Explorer and click Create here. And you can choose the region, give it a new name. I'm going to call it ADX Blaze or something like that, ADX Blaze 1. And you can choose a region. I've been working with East US for most of my stuff. Now, this gives you the ability to create the kind of workload that you're going to be doing with. Dev test is fine for demoware. Storage optimize is basically going to use more premium storage. Compute optimize is going to give you more compute. Depending on which one of these you need, depends on which one that you'll choose. If you're going to be storing a lot of data, that needs to be high performance storage. That's for ingestion and that kind of thing. Choose this one. If you're going to be doing a lot of complex analysis, choose this one. I'm going to use dev test, which is fine for my workloads. Now, the scale, you can optimize for auto scale if you want to do that here, but I'm going to be using manual scale because I'm using a dev test cluster. Now, this is where you need to turn something on. Turn on stream ingestion here because this is going to allow us to integrate with the change feed from Cosmos DB. And that allows us to create a new stream connection from Cosmos DB and ingest that data. It also works for things like blob storage and event hubs as well. So this is the one I'm going to choose for this option here. Now, the rest of this, you can pretty much just take the defaults on for demos, but you could review some of those settings if you want to for the kinds of integrations that you might want to do for networking or security or whatever it might be that you're trying to handle with your Data Explorer cluster. Now I'm going to click Create here, and Data Explorer is going to create an instance of this. And I created the instance here, but it's not needed. I'm just going to let that run, but I'm going to use my one that I already created here to show you the integrations that are done with that particular instance. Now, I've already created the database for Cosmos DB, and this is my Azure Data Explorer cluster here. Now, to get this started, you need to create a database. You can simply just add a new database to this. And this is where you can set up a new database for this. And setting up the database is pretty straightforward. If I just call it ADX1 or something like that, you can set up a retention policy. Now, for analytics data, having a retention policy is probably fine. For a shorter retention policy, if you don't plan on doing any kind of analytics beyond, say, 6 months, set it to 180 days. And the cache period is just more of a speed layer, so you can set that cache period to 14 days or whatever it might be. But that will cut down on your storage if you just have these kind of retention policies here. Now, if you're just going to be using this for analytics purposes, this is probably fine. If you're going to be using it for any kind of long-term storage, you might want to consider using a much more generous retention policy, or just using an unlimited days for the retention period as well. But whatever you do, just make sure that you figure that out, because that'll help keep the size of the cluster down and make your queries more performant, but also keep the cost down as well, especially if you're using this not as the primary source of the data, which in my case is going to be Cosmos DB. Now, once you have your database created, you have to create a table in the database, and you can do that with a query. Now, the queries that you use for this use a language called Custo, and Custo queries are basically a kind of query that is using this query language right here. Now, I'm going to show you what this one looks like here in a minute. But you basically just create a table against the particular database that you create, and that's just a simple command that's called create table, and then you basically just identify the columns in that table. Now, Azure Data Explorer is a column store database of sort where you can have the columns in the database defined, but the columns can also support things like JSON data. So you can actually have structured and semi-structured data in the same table, and you can query against that semi-structured data in the context of a structured table. So it gives you the ability to do both structured and unstructured data in the same database and same data table. And so it allows you to have more than just two-dimensional structures if you want to. But for this purposes here, basically what I'm going to do is create something like a fact table that's going to summarize my data, that I can summarize my data from, rather. And I'm going to basically just be taking all of the data from Cosmos DB and then reporting it into this database on the particular facts that I want to look at, which in this case would be things like CPU load and CPU temperature and battery percentage. But I also want some of those dimensional pieces with it, like the device ID and then the timestamp as well, that allow me to summarize the data in different ways. So with this in mind, I can create this table and just run that command. Now, once you create a command, create a table, there's also a second step that you have to do, and that's basically to create an ingestion mapping. And this takes the mappings from your document source and maps them onto the columns inside of your database, which in my case is the documents that are stored in my Cosmos DB instance. So to kind of show you what that document looks like, here's a sample that I pulled from the database. And this is what I'm working with here. So these are the system properties. Basically, it's the IoT Hub stuff that was added to the document. This is what was sent up from the actual device. This is telling me the CPU temp and the CPU load, and also the battery percentage. And those are the three pieces of data I'm interested in. And then this is the metadata that came through as part of the Cosmos DB document as well. And this tells me when it landed in the Cosmos DB database. So depending on what timestamp I want to use, I could use this timestamp. This was timestamp when it left my device. And this is the timestamp where it landed on the IoT Hub. So I have three different timestamps on this particular data. But I'm going to go with this one down here, which is the one that I'm going to integrate with this particular piece of data. So this is the document I'm working with. So basically, I'm just going to be mapping the document properties here onto columns in my ADX Cluster database, which is basically just using a very similar selection language like we see whenever we're doing very similar things in other things like SQL. You basically just say the root, which is represented by $, and then you do the property path, which in this case would be .id for the ID of the record. And then you can do the timestamp, and this is just doing a datetime conversion. This is giving me the three dimensions that are rather facts I'm going to look at, which is CPU load, temp, and battery percent. And this is my device ID that I'm interested in. And that's another dimension that will allow me to basically analyze the data as well. And so once you create the mappings and the database, you're ready to set up the integrations, which itself is pretty straightforward. So let's go ahead and do that part now. So once you've created the mapping and the table, the next thing to do is integrate Cosmos DB to get that data flowing. That's pretty straightforward. So you can just go over here to databases, click on IoT telemetry, click on data connections, and you can then select Cosmos DB, and that will launch a wizard right here. Another way to get to that is to just go to the overview tab in your Data Explorer cluster right here, and make sure you're on Get Started, and you'll see in data ingestion right here. It's the same thing. So you just basically pick a source, and then you can fill out the form. So filling out the form is pretty easy. So you can just do IoT from Cosmos or something like that. This is just a name. And then you pick the subscription, pick your database, your account, then your database, and then your container. And then from there, you can then select the table you want to use, and then the column mapping that you want to use. And then this is just basically choose when things start coming in from. You can either start from basically a date time in the past, or you can just do from the beginning of time. And I'm going to set this to maybe, I don't know, let's try it from about, I think I have some data out there that's probably outstanding. So let's put this out there for just about 23 minutes ago at around 3 o'clock, I guess. And then click create, and that'll take a few seconds to create that integration. But once that integration is done, the data is going to start flowing into your ADX cluster, because it's basically subscribing to the change feed in Cosmos DB, and any historical data or any new data is going to be flowing into ADX now, and then you can use queries to analyze that data. So let's let this collect some data, and once that's done, we'll run some queries against it and just see what that looks like. Okay, now that the database has some data in it, you can just simply select the database, just double click in and delete that pipe, and then you can just run a query just by running the table name, and that's like select star in SQL, and it's just going to pull back all the records in that database. So this has been collecting a couple of records, and you can see that it's just a pretty straightforward table. using an ID, and there's all the three facts that I want to look at. And these are some dimensional data over here, so the device and the timestamp. And if you can get a different view of it by looking at it like this as well. If you wanted to look at a particular column that had JSON data, it would show you a parsed version of that JSON data right here. So this allows me to see that data. So let's run a query against this to kind of see what it looks like with some telemetry summary. So basically what I'm going to do is create a summarized view of this data. So basically average it. I'm going to take what is the average CPU load, what is the average temperature, and what is these two summarize. And basically what I'm doing it is by device ID, so this fact right here, and then I'm going to do it on 5-minute intervals using the timestamp. Now there's ways to use things like sliding windows and tumbling windows and other kinds of ways of slicing data in this particular query language, but this one works for many of the use cases, which is basically just a tumbling window view of the data for some analytics. So if I run that, it's pretty quick. Even in a dev test cluster, it's able to summarize that data because the data is stored in an optimized form that's going to work better for these kinds of queries than what you would typically get in a transactional store like Cosmos DB. So if I was going to be doing some kind of real-time analytics, this is the way I would choose to do that. And then I could get a runtime running average of things like that, or I could run any number of different kinds of queries using Custo. Now, Custo itself has a slight learning curve to it. It's not crazy hard to learn. If you're familiar with SQL, this will feel very similar to that, but it's not exactly one-to-one mapping. They've tried to optimize it for doing these kinds of things. So instead of doing a group by and then selecting columns and then doing summaries on selected columns and all that, you basically can just do that all in one line right there. So again, a very easy to use query language, and it can join and do all that other stuff too. But this one is just specifically designed more with the kind of analytics that you would do for near real-time data processing, which is where ADX is really a useful tool. Now, I hope to explore ADX in future videos, but for today, this is where we're going to look at it and how we're going to integrate it with Cosmos DB.